Hello everyone, I am K. Yogeshwaran, Assistant Professor, EC Department from Kalainar Karnataka Institute of Technology, Coimbatore. I am going to present about ASIC Design Flow. First, we know about what is meant by ASIC and FPGA. ASIC means Application Specific Integrated Circuit. It is a one kind of IC that is built for specific application process. Specific means particular. Next, FPGA means Field Programmable Gate Array. It is also a one kind of IC that is built for general purpose application. It can be programmed in the field after manufacture. Next, main advantage of ASIC, it can be improved speed because it is specifically designed to do one application, one thing. Main disadvantage is it can be more expensive design compared to FPGA. In this slide, basic structure of ASIC design flow are described here. The sequence of steps to design an ASIC is known as ASIC design flow. The various steps involved in ASIC flow are given below. The design flow basically classified into two design. First one is logical design, second one is physical design. Logical design consists of following steps: design entry, logical synthesis, system partitioning, pre-layout simulation. Physical design consists of following steps. First one is floor planning, placement, routing, circuit extraction, post-layout simulation. The main difference between front end and back end is front end means designing and verification part. Back end means development and fabrication part. In this slide, some basic definitions are available of physical and logical design. Next one, design entry. Design entry is a stage where the microarchitecture is implemented in hardware description language like VHDL, Verilog, System Verilog or schematic editor. In entry level, mostly HDL are used in nowadays because main advantage is complexity reduced compared to the schematic editor. Second advantage is HDL are independent of process technology and can be reused over time. Second step is logical synthesis. Logical synthesis is the process of converting behavior level design to gate level design. Behavioral means something RTL design. That means VHDL or Verilog HDL. Gate level means some AND gate, OR gate, latches, muxes, that's all. Next one, it generally helps to produce the netlist. Netlist contain information on the cells used, their interconnection, area used and other details. In this figure, synthesis tool is used to convert from HDL to netlist form. Xilinx, Encounter RTL, Precision RTL is the mostly used synthesis tool. Next one, system partitioning. Main partitioning goal is partitioning of a system into number of ASIC. Main objective, minimize the number of external connection between each ASIC. Partitioning means large design into small ASIC design. This is done mainly to separate the different functional blocks and also to make placement and routing easier. In this figure, explains how to partitioning the system. Left hand IC, in left hand side, 1, 2, 3, 4 gates are placed in one IC. 5, 6, 7, 8 gates are another IC. In right hand side, 1, 2, 5, 7 gates are placed in one IC. 4, 5, 6, 8 gates are placed in the another IC. Compared to these ICs, partitioning is very efficient because compared to the ICs, right hand side partitioning is very efficient because reducing the routing connection. Fourth step is pre-layout simulation. In pre-layout simulation, allows checking whether the design function are correct or not. Next, gate level functionality and timing details also can be verified. It is also called functional verification. In this simulation, the design function was not correct. The process repeatedly goes to the design entry level. Step 5, floor planning. Floor planning main goal is calculate the size of block and assign them location. Objective is keep highly connected blocks physically close to each other. It is the first step of physical design flow. Floor planning means arrange the blocks of netlist on a chip. It is also called roughly placement or tentative placement or approximately placement. This is classified of two types of floor planning. First one is slicing floor planning. Second one is non-slicing floor planning. So in slicing floor planning, the blocks are subdividing. In non-slicing floor planning, the blocks are not subdividing. This is the structure of slicing and non-slicing floor planning. Next one is sixth step, placement. Main goal of placement, assign the interconnect areas and the location of the logic cell within a flexible block. Objective, minimize the ASIC area and the interconnect. Placement basic definition is decide the location of cells in a block. Placement is much more suited to automation than floor plan. This is the placement classification. First one type is globally placement, second one is detailed placement. Globally placement is approximate location. Detailed placement is detailed placement. Next, seventh step is routing. Routing is the connection between cells and block. It is the process of creating physical connection based on logical connectivity. It is classified into two types. One is global routing, another one is detailed routing. Global routing means tentatively routing or approximately routing. Detailed routing is detailed routing or exact routing. This is the structure of approximate routing and detailed routing. Next, eighth step is circuit extraction. Circuit extraction means determine the resistance and capacitance value of the interconnect routing. It is basically classified into two types. One is physical domain, second one is electrical domain. Physical domain means that physical information that are shapes of the design are located. In the electrical domain, some electrical information are provided. Ninth step, post layout simulation. Post layout simulation, you can extract the parasitic interconnect, and to verify the functional simulation still works with accurate timing. In post layout simulation, some methodologies are used. First one is DRC, design rule checking. Second one is ERC, electrical rules checking. Third one is LVS, layout versus schematic check. In the simulation, the physical design was not connected, not working. The process repeatedly goes to floor planning. Thank you.